All right, so for this game, we have what, roughly speaking, kind of works out like an in and out game. It's not quite an in and out game because we're going to have doubles here, but we essentially still only have two groups and a bunch of companies which are going to be assigned to these two groups. So we have our 5-year bond group and our 10-year bond group. Now, the elements themselves happen to be GHL, R, S, and V. And it's worth noting, they do play out the spacing and how this is going to work out. Essentially, what's going to happen is each of these two is going to have exactly 4 spaces assigned. There's going to be 4 companies assigned to each one. And what we're told is that 2 of the companies are going to show up in both of these groups. So what we can actually do is we can say that because 2 of the companies are going to show up on both sides, we can even kind of equate these in a sense. We can say that we're going to have these 2 spaces that are going to be the same as each other, and then the other 2 spaces on both groups are going to be independent. Those are going to be separate. So just to kind of, I guess, visually show that. So from there, I guess let's take a look at the rules. So the first rule tells us that H cannot do the same type of bond as L. So essentially, H and L cannot be on the same side. Now that's already kind of restrictive. That's important because we know that everybody has to show up in some capacity. So if H and L cannot show up on the same side, they'll have to show up on different sides. On top of that, you definitely know that these guys right here are not going to be your doubles anymore because then they would end up together. So we can kind of leave a placeholder for one of H or L on both sides here because you'll have to have one of H or L on each of the 2 sides. And we know that they'll be in one of the single spots because these are definitely not going to double up. Next, if V does 5-year bonds, then S will do both types of bonds. So we can say if V is doing 5s, then S will have to do both 5 and 10. The contrapositive here, of course, will then say if we don't have S doing 5 or... Actually, we can kind of simplify this because arguably, all we're really saying here is that if V does 5, then S will do both. So the contrapositive really could say simply that if we don't have S doubling up, if we don't have S going twice, then V will not be able to do 5, which means V will have to do 10. Actually, we should probably clarify this further now because we could technically in this game, right, certain elements could go on both sides, right? So you want to be cautious here because when we say that V will have to do 10 because V will not do 5, we probably should clarify here that not only is V doing 10, but rather that V is doing 10 only. Because it's not just that he has to do 10, it's that he cannot possibly trigger being under the 5 side, right? So if S does not do both, then not only do we have to have V on 10, but we'll only have V on 10 because in that scenario, we could not possibly have had V on the 5. Next, the last rule says that if L does 10-year bonds, then R will as well. So if L does 10s, then R does 10s as well. Contrapositive then would say that, and again actually here, so it might be tempting to say something like if R does 5s, but this wouldn't really be complete or even accurate really, because the rule really should be if R didn't do 10s. Now if R does 5, that doesn't preclude the possibility that he could have also done 10. So it's not fair to say that any time that you see R in 5, it triggers the contrapositive. Rather, the contrapositive here should say, if we don't have R in 10, then we can't have L in 10 either, which means L will have to go in 5. And very similar to this rule, we should probably clarify that not only is L under 5, but he will be under 5 only. In other words, L in that scenario cannot be in 10. So from here, I guess we can kind of go into the questions themselves. It might be worth kind of brainstorming who could double up, but it actually looks like we have a bit of flexibility. I mean, we definitely know that H and L can't double up because of that first rule that H and L cannot be together, but otherwise it actually looks pretty open. Like over here, for example, when we say that if V is in 5, then S will double up. But in that scenario, V also could have been doubling up as well, in which case that doesn't really stop anybody from doubling up. Also here, if L is in 10, then R is in 10, but R also could have been in 5 as well in that situation, in which case it doesn't seem like there's really any restrictions on anybody else doubling. So it doesn't seem like we can do much more with this. So let's take a look at the questions themselves. Now, the first question we have here, number 18, is our exclusion question. As usual, we do these by the rules. So the first rule told us that H and L cannot be together, which effectively also meant that we'll have to have one of H or L on one side and then one of H or L on the other side as well. So answer choice A looks actually pretty good. So we have an H on the 5 and an L on the other side, so we're good. Answer choice B has H on one side. Actually, you'll notice answer choice B has H on the other side also. So answer choice B doesn't work because then there's no L's, in fact, at all, and that wouldn't work. Next, answer choice C has H on the one side and both of them on the other side, so that also doesn't work. Answer choice D has L on one side and H on the other, we're good. And answer choice E has L on one side and H on the other, we're also good. Next, so for this rule, if V is on 5, so we should look for cases where V is on 5. So answer choice A, we don't have V on 5, so this doesn't really apply. Next, answer choices B and C are already out. Answer choice D does not have V on 5, so that also doesn't apply. And answer choice E has V on 5, but in that scenario, S should be doubling up. We should have S on both sides, which you'll notice we do not. We only have S on the 10-year bonds there, so we can disqualify answer choice E from the answers. Next, now we're just down to A and D. So for the last rule, if L is on 10, then R should be there as well. Let's take a look. Answer choice A has L on 10, but then R is also supposed to be there, which it isn't. So that on its own would disqualify answer choice A from the answer choices. And that leaves us with answer choice D as the best answer to question number 18. Now, I guess just for, good habits, it's worth plugging that into the board. So under the 5-year bonds, we have GLRS. And under the 10-year bonds, we have GHSV. And I guess since we had these kind of highlighted separately, so we could kind of do something similar here, where we'll just highlight that the G's are duplicated and the S's are duplicated, and the other guys, L, R, H, V, are independent, which is how it's supposed to work. So next, the local question. So we have question number 19 here, which says, if neither L nor V do 5-year bonds. Well, first of all, if neither L or V are under 5, that means that they're definitely going to be under 10, and moreover, they're definitely not going to be duplicates, right? Because, well, they're not under 5. So we can say that L and V are essentially going to take up our single spots on this side, and then we're still going to have our doubles spots, which they're going to share with the 5s. Next, what else can we do? Well, first of all, we already know that if L is on 10, which it is, then R is supposed to be there as well, which means we can lock R into this position, but that means that R is one of your doubles, which means R is also going to have to be in the 5s. Next, we know that if V is on 5, well, this doesn't apply because V is on 10. H and L obviously can't be together, and since we have L over here, that means that H is going to take one of the single spots on this side. And I guess otherwise, it doesn't look like the other rules do much for us right now. So let's see what we can do with what we have. The question itself asks, which of the following now must be true? Answer choice A, G does both types. Well, we don't know that. He could, for the record, still be the double that we have here, but he doesn't have to. Answer choice B, R does both types, and yes, that definitely has to be true. The best answer for question number 19 then is answer choice B. Next, number 20 is global. We'll come back to that one in just a moment. Let's take a look at number 21. So if S and V offer only bonds of a different type from one another, so essentially in this scenario, S and V are not going to be together. Well, first of all, if S and V are not going to be together, that means that they'll be singles, just like H and L. So we can kind of reserve our placeholders. We'll have to have basically one of H or L still, and one of S or V, and then the other guys are going to be, as usual, the doubles. Except we can take this a few steps further. First of all, we can't really trigger this guy. V can't go on 5 anymore, because for V to go on 5, S would have to double, which at the moment it can't, which means that the V is actually going to be the one who happens to be on 10, while the S is going to be the one that happens to be on 5. Next, what else can we do here? Well, we know that H and L can't be together. That's taken care of. We know that if L is on 10, then R is there as well. So that doesn't do much for us either. So at this point, it seems... Oh, actually, wait a minute. We have everybody else remaining, right? So our doubles are definitely going to have to be G and R on both sides, just because there's nobody else to double up anymore. So that's actually taken care of. In terms of H and L, can we do a little bit more here? Well, no, because R is definitely on 10, so we can trigger L10, but we don't have to. So the question now becomes, which of the following could be the pair of corporations that offer only 10-year bonds? Well, under the 10-year bonds, the singles, the guys that offer only 10-year bonds, are going to have to be V and one of H or L. So answer choice A, L and V, that looks like that could work. Just in case, let's take a look at the rest. L and R, well, no, we have to have one of H or L with V over here. So that's out. Next, can we do H and R? Well, no, same problem. We can't have R be your singles here. Can we do G and L? And again, G can't be one of the singles. And E, can we do G and H? No, G can't be one of the singles. So as we said, the best answer to number 21 then becomes A. Next, we have question number 22 is global. We'll come back to that one in just a moment. Let's take a look at number 23. So if G offers only one type of bond and H offers only the other type of bond, which effectively at this point just means that G and H are not going to be together. Now, first of all, obviously that means that, well, the question itself tells us that they're going to be singles. And I guess we can take a bit of a step further here. We can say that what's going to happen is that we're going to have G essentially on the one side and H on the other side, but H disqualifies the L, which means L is going to actually end up with the G. That said, though, I guess, do we know which side they go on? I mean, this rule might apply. So if L is on 10, then R would have to be on 10 as well. But that actually seemingly could work because you could have R be your double, and that seems like it would be fine. I mean, if V is on 5, I mean, it doesn't seem to restrict us too much. You know what? Worst case scenario, what we could do here is we could just split this board into two and kind of see where it takes us, because essentially the GL and the H are all going to be singles, right? So we can say either we're going to have a GL on one side and H on the other, or we're going to have the GL on the other side and H on the one. Now, in both cases, we still have to have our doubles to take care of, and we're going to have a space on the other side, because we have to have that single remaining here and that single remaining here. So from here, can we do more damage? Well, we do know that, okay, so in this scenario, if L is on 10, which here it is, then we'll have to have R doubling up effectively. Other than that, I mean, could we still do this if V is on 5? Well, actually, yeah, because in both cases, we could put V here and S could double up, or not. We could, of course, put V here as a double, and then S could... Actually, could we do that? So in the bottom scenario, can we have V be our double? Well, no, actually, that wouldn't work, because if we put the V here and here, that triggers the V5 rule, and then S is going to have to double up, for whom we have no more room. So actually, we can take this one step further. V cannot be the double here. So we can actually say that in this bottom scenario, V will have to be a single, and then S is going to have to be the double. So that at least takes care of that. Now, in the top scenario, we could still have V be the double. It can go on both sides, and S could double as well. Or arguably, V could go here, in which case we have a little bit of flexibility. So you know what? Let's see what we can do with what we have. The question itself asks, which of the following now must be true? Answer choice A. G offers 10-year bonds. I mean, it could, but it could also just be under the 5, so that doesn't have to be true. A gets disqualified. Next, R offers 5-year bonds. Does R have to do the 5-year bonds? Well, I mean, in this scenario, R is definitely doing 5-year bonds, but in this scenario, couldn't we place the R over here, and then we said we could have V and S be the doubles? This doesn't seem like it would have to be true, so answer choice B is out. Next, C, R offers 10-year bonds. Does that have to be true? Well, again, in this scenario, R definitely does 10-year bonds, but in this scenario, does R have... Well, actually, it does seem like it would have to, because either R is going to go here as a single, but alternatively, R is going to double up, in which case it's still going to do 10-year bonds. Actually, this is pretty good. It looks like R does, in fact, have to do 10-year bonds. Answer choice C is viable. Just in case, let's take a look at the other two. V does 5-year bonds. Does V have to do 5-year bonds? Well, again, in this scenario, it does. But in this scenario, we could arguably put V here, and I guess R and S could be your doubles, in which case we're still good. So answer choice D then gets disqualified. And lastly, answer choice E, V does 10-year bonds. Well, in this bottom scenario, that definitely doesn't have to be true because we have V over here under the 5s, which means E gets disqualified, and the best answer to number 23 then becomes C. Next, number 20, let's take a look at the globals. We have, which of the following pairs of corporations could be the two that offer both types of bonds? So basically, who could be the doubles? Well, first of all, right from the gate, we know that H and L could not be your doubles. So we can cross off any answer choice that happens to have an H or an L in it. So that easily gets rid of answer choice A. It also gets rid of answer choice C. And I guess from here, let's take a look at this kind of step by step. Answer choice B, what do we have? G and V. So could G and V be our doubles? Well, historically, we haven't seen it happen yet. We haven't really seen a case where G and V were your doubles. But what do we know? Well, actually, wait a minute. If V doubles up, then he's definitely going to be in 5, right? But then if V is in 5, then S is going to have to be your double, which means that wouldn't work because then it's not G and V who are your doubles, because if V is one of your doubles, then S is going to be the other one. So that actually disqualifies answer choice B. Next, answer choice D, R and V. So could R and V be the doubles? Well, actually, I guess we're running into a pretty similar issue. If V is one of your doubles, then S is going to be the other of your doubles, which means that doesn't work. Lastly, answer choice E, S and V, and I guess that triggers this condition. If V is a double, then S is the other double, which we're good with. So the best answer choice to question number 20 then is E. Lastly, we have question number 22. Let's take a look. Which of the following pairs of corporations could be the two that offer only 5-year bonds? So essentially, we're looking for which two could be the singles on the 5-year side. Well, first of all, we know that one of your singles on the 5, in fact, on both sides, is going to have to be one of H or L. So we can start with that. So answer choice A looks okay because we have an H there. B, you'll notice, gets automatically disqualified because there's no H or L, which means that those two can't be your singles. One of your singles here is definitely going to be one of H or L. Next, answer choice C, H and L is certainly not going to work because you can't have both on the same side. Answer choice D, H and R. So actually, maybe we could have H and R be the singles here. You know, let's hold off on that for a moment. Answer choice E, S, and V. Well, no, we said that you have to have one of H or L be your singles. So that gets rid of answer choice E. So let's go back. Answer choice A, G and H. Could G and H be our singles? Well, we haven't quite seen it happen yet, although we do have an opportunity over here in this scenario, because arguably G hasn't been accommodated yet, and we have an H with an empty here. So hypothetically, if we were to adapt this scenario and say we were to place the G over here, then could we make this work? I guess who's left over? That would be S, and S would have to be the double. And yeah, actually, it's worth noting that looks like that would be fine, in which case that would be pretty good proof that H and G could be your two singles. So the best answer for question number 22 then should be A. Just in case though, let's take a quick look at the other one. So we had answer choice D. Could we have H and R as the two singles on the 5 side? Well, actually, I guess one thing that gets triggered is that if H and R are your singles, that would mean that R is not on 10, because by definition, H and R are singles on 5. And if R is not on 10, then we're actually supposed to have L be a single on the 5, which means that you couldn't have H and R be your singles, because if R is a single on 5, i.e. he is not in 10, then L would also have to be a single on 5, and that wouldn't work. So answer choice D gets disqualified, and we're right back to the same point, which is the best answer for 22 is A.